In the next few videos, we're going to introduce the concept of logarithms and look at the logarithmic function. The easiest way to begin to understand logarithms is with some examples. 2 to the power of 5, going back to exponents, means multiply 5 2's together. That's going to give you 32. If we think of this in terms of functions, we're taking the exponential function 2 to the power of x, inputting a 5 into the spot where x was, in this case into the exponent, and then evaluating. We get 32 as our output. The logarithmic function, abbreviated as log, works in the opposite direction. Again, we have a base here written as a subscript this time of 2, and we say log base 2 of 32, that's how you read this, log base 2 of 32 is equal to 5. In this case, what you're doing is asking what exponent do I need to use on 2 in order to get 32, and the answer is 5. So it's working in the opposite direction. In other words, the logarithmic function is the inverse of the exponential function, and we'll develop that concept a bit more in a future video. At this point already, though, you can see that whereas if you put an input of 5 into an exponential function and get an output of 32, in a logarithmic function, it works the opposite way. You put an input of 32 in and get an output of 5. Same numbers are paired together, but we swap which one's the input and the output. And that's characteristic of inverse functions. So a logarithm is really asking what exponent is needed. Again, log base 3 of 81 is asking us what exponent is needed on 3 in order to get to 81. And we know that 3 to the power of 4 is equal to 81, so this is the exponent that we're missing. So log base 3 of 81 is equal to 4. This whole thing evaluates to a single number. That means that exponential equations can be rewritten as logarithmic equations and vice versa. If we have an exponential equation like this, 3 to the power of 2 is equal to 9, we can rewrite that as the logarithmic equation log base 3 of 9 is equal to 2. Notice the way the pattern works. The 3 is always in the base. As a subscript here in the log function, that's called the base, or as the base in the exponential function. What swaps sides on the equation is the 9 and the 2. Similarly, if 5 to the power of 3 is equal to 125, we can write log base 5 of 125 is equal to 3. Both of these equations are representing the same relationship, they're just doing it in a different way. We can start from the log equation, log base 2 of 64 is equal to 6. That's telling us that as an exponential equation, 2 to the power of 6 is equal to 64. We can do the same thing when we have negative exponents. If 7 to the power of negative 1 is 1/7, then using the same pattern as we did before, that means log base 7 of 1/7 is equal to negative 1. Going in the opposite direction, if log base 3 of 1/9 is equal to negative 2, that's telling us that 3 to the power of negative 2 is equal to 1/9. If 3 to the power of 1 is equal to 3, the corresponding logarithmic equation is log base 3 of 3 is equal to 1. It's saying what exponent do I need to use on 3 to get to 3, and that's 1. Similarly, if 4 to the power of 0 is equal to 1, that means that log base 4 of 1 is equal to 0. What exponent do I need to use on 4 to get to 1? I need to use a 0, so log base 4 of 1 is 0. Again, a logarithm is asking what exponent is needed. Here's another way to think about it if it helps. Let's go back to multiplication and division. 3 times 5 is really another way of stating an addition statement. Add 5 3's together, and you get 15. So 3 times 5 is asking, what do I get if I add 5 3's together? Whereas the related division statement, 15 divided by 3, is asking how many 3's do I need to add together to get 15? It's asking the same thing, but in a different way. Similarly, 3 to the power of 5 is asking, what do I get if I multiply 5 3's together? And the answer is 243. Whereas log base 3 of 243 is asking, how many 3's do I need to multiply together to get 243? In other words, what exponent is missing? Remember, the exponent tells you how many 3's to multiply together. This 5 means multiply 5 3's together. So if that's helpful, that's another way of thinking about it.